Now, the next thing that we'll want to tackle, we'll want to look at our left and our right diagonal. And extracting these is going to be a little bit tricky, but let's see if we can walk through the logic. I know that I have two diagonals on any given board of 3x3 tic-tac-toe. I have my upper left element, my center element, and my lower right element. Now, there's a couple of different ways that we can go about extracting these values. I could check if grab the 0th thing from the 0th row, the 1th thing from the 1th row, the 2th thing or the 2nd thing from the 2nd row or the 2th row, and go about my life like that. And so let's see if we can implement our left diagonal using that logic. So this takes a board, and I'm going to iterate over each row. So for I, comma, row, in rows, and you can see how these functions start to just build upon each other. And of course, I'll enumerate this. So when I'm on the 0th row, I want to yield out the 0th thing. When I'm on the 1st row, I want to yield out the 1st thing. And before we abstract this, I want to just show you that this will work. I can print my board 0 here. That's my 1st row, that's my 1st element. That is my 2nd row, that's my 2nd element, and this is my 3rd row and my 3rd element. So let's see if we can just quickly encapsulate this and return it. I can use a tuple to structure these elements, and I'll of course add just a little spacing for myself in the future, and add some commas there. So let's take a look at our left diagonal. I'll comment out this extra code just so we don't have to look at it for the time being, and see if ldiag on our board works the way we think it does. We can see here that I've got an X, O, O, and if I look at my left diagonal, I see X, and then an O, and then an O. Of course, now we would revisit this logic. Okay, we've hard-coded some values, but we did get something that worked. And this is very important whenever you're prototyping. It doesn't matter how adaptable your implementation is going to be. What matters is first delivering, right, a minimal viable product. And if that means hard coding some values to get something out the door just to prove it works, go ahead and do that. You can always revisit code and make it better. Don't waste your time trying to make it better in the very first pass. So my second pass might look like something like this. And now, of course, we would need to produce these values. So let's see if I unpack these here. We see that we get X and then O and then O. And that is the same output that we had before. And of course, now I'm not relying on some hard-coded values here. So this gets us decently far. I am still, of course, limited by the board, but let's see if we can implement something similar for our right diagonal. Now, I'll start with the easy thing, and that will be some hard-coded values here. And let's take a look at our right diagonal in this case. Now, I'm looking for an X here, and then an O, and then let's change this to an X just to get something a little bit different, maybe even a W, just to keep things unique. And so this will be my very first row. I want the last thing, then I want the second to last thing, and then I want the third to last thing, which is of course going to be my first thing. And we see that I produce X, O, and W. And this could be my solution for this problem, but of course I'll want this to at least try and adapt to something in the future, maybe to a larger board size. And so we can implement our our solution that we use in our left diagonal, but instead of producing the I thing from the row, let's see about producing the negative I thing from our diagonal. Now, this should give me X, O, and W, and it has given us X, O, and O. So we'll need to think about our logic here. Right now, this is asking for the negative 0th thing. And so we might want to, and the reason I point that out, the negative 0th thing is just going to be the 0th thing. So we're starting here, we're grabbing that, and then we're grabbing the negative 1th thing over here. And then, of course, we're grabbing our next O. And so what I would need to do is, instead of starting at 0, I'd simply start at 1. And this gives us our negative 1 on the first loop, -2 on second, and then of course -3 on third loop, which lines up exactly with what you saw my original solution here would be. So I'll keep this code just so we can revisit it in the future, just so we have it on hand. But now I have my winning functions. I have my rows, I have my columns, I have my left and my right diagonal, and I have my single function, my win function, to determine if any of those are going to be winners. So what this might look like, I might go ahead and say this. I have all of my conditions. I'm going to iterate right over my rows, over my columns, over my, and this isn't so much iteration because my left diagonal and my right diagonal are just going to be single entities here. So let's do this, L-diag here. And this is going to be the left diagonal of my board. I don't need to enumerate this since there's only one in this case. And so I can actually get rid of this loop completely and say if there's a winner on the L diagonal of my board here. And so let's see if this works. If one on, this will be L diag there, just like that. And then there's no I variable in this printout. I want to see if I can actually get this to work on my left diagonal. So let's put a win of all O's. It does look like that worked here. If I replace that with an X, we get no winner. So this is going so good so far. We can reverse this logic or apply the same logic with our right diagonal here. And if I change my XO, we'll have W win along the right diagonal. We see that W did win on the R diag or the right diagonal. And so now we have all of our logic. I'm checking here, right, if each row won. Check if there's a win in the row. Then I'm checking if there's a win in the column. Then I'm checking if there's a win on the left diagonal. And then finally check if there's a win on the right diagonal. And this is the core logic of my game of tic-tac-toe here. Now, we could go back and refactor a little bit of this. I could actually iterate over all these win conditions and unpack them, but I would need to be very careful about checking or determining which win condition I'm actually checking. And so I think, you know, as a first pass, or a pass 1.5 here, this gets us pretty close to our solution. The last thing that I'll want to do is probably maybe bundle all of this logic up into a single entry point so that my users, or the people who use my library, don't need to compose all of these elements. And so let's call this a win check. And so that's a single winner. And so this will be a game winner. And instead of printing things out, we'll of course just pass along, right, our two variables, our win and our victor here. And so I may even go as far to pass in the whole board to this function. So this will take the board here, and I can set some default values and say, right, return a winner or not. Let's see here. We have our winner there, perfect. I could short circuit. Now the thing about short circuiting here, this logic, is if I have a win in one place, I'm not going to report that there could be two wins, but you can think in our standard game of tic-tac-toe, once somebody wins, we're not playing anymore. So I think this short-circuiting logic is totally fine for us to use. Now, I do need to be careful to check if there is a winner here and return those appropriately, since I don't want to overwrite these variables. And you can think I'm running into that problem I spoke about earlier of, well, if there was a winner, how would I verify which condition was won? What I could do, I could return the function that was used to evaluate whether or not there was a winner, but that's going to require a little bit more structuring. And so I think for this case, we're not looking necessarily to return something meaningful to the user. We're simply going to just print out whether or not somebody won in this case. And so this wouldn't be a function that you would use to actually propagate some return value. You would just use to check if somebody has won. This is kind of like this is what's going to display right on the board of my client's games here. And so, of course, we can compose, right, all of these checks using each of these individual components here that we have drafted up. So with this being our game of tic-tac-toe, let's take this to our next step, and that is going to be, of course, our code review.